Lesson 1. Drawing Equipment and Line Division. Welcome to Graphical Communication. Let us start with your essential drawing equipment. For technical drawing, you want light, precise construction lines that you can easily overdraw later with darker outlines. A 4H hard pencil is typically preferred for this task. You should avoid soft B-range pencils because they smudge and produce heavy lines that are unsuitable for construction work. Next, let us talk about set squares. Standard equipment includes an isosceles 45-degree set square and a 30 by 60-degree set square. When combined with a T-square, placing these set squares against each other produces common composite angles. For example, adding 45 and 30 gives a 75-degree angle, and adding 45 and 60 gives a 105-degree angle. Now, let us look at basic line division. If you need to find the exact midpoint of a straight line segment, you construct a perpendicular bisector. You do this by drawing equal arcs from both endpoints with your compasses so they intersect above and below the line. Joining those intersection points crosses the segment exactly at its midpoint. If you repeat this bisection, halving every segment, you divide the line into powers of 2, such as 2, 4, 8, or 16 equal parts. But what if you need a specific number, like 7 equal parts? Repeated bisection will not work. Instead, you use an auxiliary ray drawn from one endpoint. You step off equal units along this ray with your compasses, join the last point to the other endpoint of your original line, and draw parallel lines to transfer those equal divisions onto the original segment. Lesson 2. Triangles, Polygons, and Circles. In this lesson, we will explore the properties of triangles, polygons, and circles. The interior angles of any triangle always sum to exactly 180 degrees, a property fundamental for constructing triangles from given angle data. A specific type is the equilateral triangle, which has 3 equal sides and 3 equal 60-degree angles. Also, if any triangle is inscribed inside a semicircle with the diameter forming one of its sides, the angle at the circumference will always be a right angle, exactly 90 degrees. Let us move to regular hexagons. For a regular hexagon, each exterior angle is 60 degrees. When constructing one across corners, the given dimension represents the distance between opposite vertices. This distance is equal to the diameter of the circumscribed circle. Speaking of circles, a circumscribed circle or circumcircle passes through all 3 vertices of a triangle. Its center is found at the intersection of the perpendicular bisectors of the triangle's sides. Now let us identify some basic circle parts and relationships. A chord is a straight line joining any 2 points on the circumference. A tangent, however, is a line that touches the circle at exactly 1 point and is always perpendicular to the radius at that contact point. Finally, consider 2 circles touching each other. When they touch externally with no overlap, the distance between their centers is exactly the sum of their radii. If they touch internally, meaning the smaller circle lies inside the larger one sharing one contact point, the distance between their centers equals the difference of the radii. Lesson 3. Engineering Curves and Loci. Our third lesson focuses on constructing specific curves and understanding loci. An ellipse has 2 fixed points known as foci. For any point on the ellipse, the sum of its distances to these 2 foci is constant and equals the major axis length. A standard instrument method for drawing an ellipse, given its major and minor axes, is the concentric circles method. You draw 2 concentric circles with diameters equal to those axes, divide them into equal angles, and use corresponding ordinates to transfer points that map out the ellipse. Now let us define a few special loci, which trace the path of a moving point based on specific rules. If you have a circle rolling without slipping along a straight line, a fixed point on its circumference will trace out a locus called a cycloid. If you have a fixed square or circle and you unlined a taut string from its base, the free end of that string produces a curve known as an involute. Next, imagine a point that rotates about a fixed pole, while its distance from the pole increases at a constant uniform rate. This combination of angular motion and radial growth traces an Archimedean spiral, where equal angles correspond to equal radius increments. Finally, there is the helix. A helix is described as the locus of a point that travels both along and around a cylinder at a constant rate. Its path advances axially along the cylinder while maintaining constant rotation about the cylinder axis. Lesson 4. Pictorial Drawing Methods. Our final lesson covers pictorial drawing systems, contrasting isometric, oblique, and perspective techniques. Isometric drawing is a parallel projection where parallel edges stay parallel. The three principal isometric axes are drawn 120 degrees apart, commonly set with a vertical upright axis and two receding axes at 30 and 150 degrees to the horizontal. Because isometric planes are inclined to the picture plane, circles lying on isometric faces appear as ellipses. Accuracy marks in the exam require proper geometric construction of these elliptical images rather than freehand guesses. Next is oblique drawing, specifically cabinet oblique. This method is preferred when an object's most important face must remain undistorted. It keeps the front face true shape and size, meaning a circle drawn on the frontal face will appear as a true circle. The depth lines usually recede at a 45-degree angle, and lengths along them are drawn at half scale to reduce visual distortion. Finally, perspective drawing converges parallel lines to vanishing points to closely match human vision. The horizon line always represents the eye level of the viewer. In one-point perspective, faces parallel to the picture plane keep their true shape and outline, while the principal set of receding lines goes to a single vanishing point on the eye level line. Two-point perspective is especially suitable for showing a corner view of a building or product, placing the object so two sets of horizontal edges recede to two separate vanishing points on the horizon.
Thanks for watching. For free practice questions, study guides, and flashcards, visit exampreprise.com. Good luck on your exam!